Let's get started then. Good afternoon, everyone.
Good afternoon.
My name is Marc Plogas. I'm based in Berlin, Germany, and I'm an Azure App Consult engineer working for Microsoft. In my day-to-day work, I'm supporting startups with their technical questions around Azure, especially cloud-native architecture, IoT, machine learning, and analytics. There is someone waiting in the lobby. I have a strong connection to the mixed reality community. I was part of the original Oculus Rift Kickstarter back then, and I have helped game studios adopting Windows mixed reality back in 2018 and 2019. My Azure App Consult team is also supporting mixed reality partners with their adoption of Azure mixed reality services or Azure services in general on mixed reality platforms. I also recently published a book about Windows App SDK that I have written with a friend, and I'm running a podcast with the same friend called Debugging on Live. Now get started. Metaverse, mixed reality. Well, the term of mixed reality is defined by blending the real or physical world with the virtual or digital world to produce a new environment. Both physical and virtual objects can coexist and can be interacted with as if they were real. Now, let's have a look at the definition of the reality spectrum. On the left side, we have the physical reality with all the objects you have around you, chairs, desks, cups, the coffee maker, or the cat next to you. On the right side, we have the digital or virtual reality that contains holograms, virtual objects, or digital data. Mixed reality spans from left to right, from physical reality to virtual reality. Unfortunately, augmented reality and virtual reality devices only cover a small part of the spectrum right now. This is due to technical limitations, but also due to missing adoption and viable use cases. The headsets are getting better with every generation, and the adoption of mixed reality is slowly improving. Hence, the metaverse is often seen as the next big wave in personal computing. Now that we have looked at the spectrum, let's take a look at the available devices on the MR spectrum. This is important to understand as we are seeing a fragmentation based on capabilities that any MR developers needs to take into account. To augment the physical reality, there are a few portable see-through devices on the market. The most important one right now is the HoloLens, but there are others such as the Magic Leap 2. The mobility of see-through devices comes with a price, namely battery, processing power, and a smaller field of view. Also, the cost per device is still limiting the use of these devices to enterprise scenarios. Other concepts to augment physical reality are mobile AR on phones or tablets and smart glasses like the Google glasses we've seen many years back. On the right side, the virtual side of the spectrum, we have the classic tethered VR headsets, such as the Valve Index, the Pimax AK, the HP Reverb G2, and so on. They run side by side to your regular flat screen displays and are mostly limited by the GPU of your workstation. Some of them also have limited see-through capabilities, thus blurring the line between the physical and digital reality. Oculus, or like its mother company Meta, is quite successful with their portable head-mounted device Oculus Quest, which brings tether-free freedom to the VR world. The latest product, the Oculus Quest Pro, is even going one step further, blurring the lines between see-through and opaque even more, allowing camera-based see-through AR with astonishing quality. This brings a few challenges for developers, however. The fragmentation of devices, which aren't cheap, often requires a focus on one device type or vendor and one market. An application developed for the HoloLens will not necessarily run on a Windows mixed reality device without modification. An application for the Oculus Rift will not run on the Magic Leap device. OpenXR reduced the required effort by a lot by acting as an abstraction layer. However, there are still differences that need to be taken into account. Different paradigms for content creation requires new roles in the development team. For example, technical artists or different user experience concepts. So when the internet gained popularity, a common misconception was bringing the newspaper style to the web. This resulted in websites that look a lot like text that look like newspapers with a lot of text and scrolling and many columns. It took a while until we figured out what is working and what isn't. The same can be observed with early mixed reality applications, where information is presented in a web or flat screen style, ignoring the capabilities and requirements of the mixed reality space. Another challenge is the complex tooling for developing mixed reality application. Let's take the regular HoloLens development cycle with Unity as an example. Setting up your project takes roughly 1 hour before you are able to add your very first 3D object to the scene. If you're lucky and well-versed, bringing this scene to the lens requires building the project in Unity first and then in Visual Studio, which takes somewhere between 4 and 15 minutes overall, depending on the complexity. So the time for deployment or time to deployment is quite high. And out of experience, this reminds me a lot of the early period of mobile development so between 2008 and 2014. So my personal prediction is it will get better at some point. And this is where I'm going to introduce StereoKit. What is StereoKit? StereoKit is a code-first, lightweight mixed reality engine developed by Nick Klingsmith. It is built around an intuitive API and brings a code-first, mixed reality-friendly UI and mixed reality interaction system for AR, VR, and flat screen scenarios. Nick started building this engine back in 2019 and released the first version to the wild in 2020. Earlier this year, StereoKit gained more attention through Nick's fantastic sessions at the Mixed Reality Dev Days in Redmond. This quick demo highlights a few StereoKit features. We are in an opaque or virtual environment. We can see the built-in interaction, including the joints. The UI framework provides interactive controls such as buttons, sliders, or radio buttons. All menus can be grabbed, moved around, and placed freely. We have access to colors. The engine provides physics simulation, a file picker, dynamic asset loading, shader support, lighting support, and of course, multiple hand gestures. So StereoKit leverages OpenXR bindings to provide support to many platforms, such as HoloLens, like HoloLens 2, Windows Mixed Reality, Oculus Quest, Oculus Desktop, SteamVR, Varjo, and Monado, and eventually everywhere where OpenXR is. It features easy to access interaction through extensible inputs like hands or eyes. UI elements and models can be turned into movable and grabbable objects by wrapping them into a handle. This is what we can see on the left-hand side. This is basically the box around it. The world object of StereoKit offers information about the real world around the user, including spatial understanding and orientation, boundary, and occlusions. This is particularly helpful when using anchors in augmented reality scenarios. Boundaries are known in VR scenarios, or usually they are also called guardian spaces. And they're used to define a safe area where you can move around freely without risking to run into furniture or hitting walls. They're usually defined through the VR system and accessible to StereoKit. The code on the left shows a snippet of the initialization of the Azure Spatial Anchors wrapper for StereoKit. The full code is available on my GitHub repository. A compiler directive allows initializing a mock instance of the service in debug builds. The service instance is then injected via constructor in the UI classes, which in turn are registered with the StereoKit stepper. This allows StereoKit to hold onto it, and because the engine uses an immediate mode UI, an update version of the menu is rendered with every frame. This might sound a little bit odd at first, but it does have some neat advantages. Since very little state is actually stored, you can add, remove, and change your UI elements with trivial and standard code structures. You will find that you often have much less UI code with far fewer places for things to go wrong. So the goal for this UI API of StereoKit is to get you up and running as fast as possible with a working UI. I would like to get back to the challenges in mixed reality development and talk about how StereoKit is trying to solve some of them. In summary, these were device fragmentation and the costs, different paradigms for tools, people involved, and user interfaces. And all this results in extra time to deployment, which of course results in higher costs. So StereoKit prioritizes mixed reality application development above all else. By building upon OpenXR, StereoKit can reach a wide array of hardware platforms without having to port or even rewrite the application code. OpenXR offers an API header files, actually multiple, and reference pages, and all of this is part of the OpenXR API specification. Additional features such as improved eye tracking or hand tracking are defined OpenXR extensions. StereoKit already incorporates a few of these extensions, and you can help to adapt new extensions as that you see fit by basically going to the GitHub page and creating a pull request. The various interactions are actually a good example of OpenXR extensions being used by StereoKit. We have the classic mixed reality controllers on the left and the HoloLens 2 hand tracking in the middle that are built in. But what if you want to use the amazing Ultra Leap, formerly known as Leap Motion hand tracking API? That is some little box that you put on your desk and which tracks your fingers using ultrasonic. So Ultraleap has released an OpenXR extension that can be easily incorporated into StereoKit. Well, actually, it already has happened, but this gives you basically an idea of how easy that would be. So the interaction system of StereoKit is very flexible and extensible as it is based on OpenXR extensions. Let's talk about development again. The bad news first, you will still need to hire a technical artist and a designer. Shaders, materials, and models are important for a nice user experience in mixed reality applications. But the actual development of the application can be done in your single IDE, be it Visual Studio or VS Code. The core of StereoKit is written in C, but most of the time you are consuming its API through C# and .NET. That means you have access to Link, HTTP client factory, classes, objects, or whatever you like most about C#. There is no IOC container though. So that's kind of like the main difference to the regular .NET application development. If you're not happy with the existing .NET and C# bindings, Feel free to contribute to the alternative bindings in Zig, V, or Rust. This slide just highlights the easy and straightforward way to get your first results in StereoKit. The first snippet just loads a model and draws the model with every step or frame. The second snippet is very easy. It's an easy menu consisting only of 2 buttons. One of them is being used to close the application. The other one simply does nothing. The window in StereoKit, basically the frame around the buttons, is grabbable by default. So the UI can always be grabbed and moved around in your scene. It also has a title, as you can see. So that is by default. Just so you, as kind of like an extra here, you can also start theming your UI. That is a bit more challenging, but this is also possible. So it's theming your UI is also a thing. So that is already pretty neat and developer friendly, but StereoKit has also some additional tricks up its sleeve. A cross-platform file picker, for example. But you may ask, what good is it if you can pick an asset from a store, but you can't load it dynamically, right? So that's why StereoKit offers that feature too. You heard it right. Dynamic asset loading without any placeholder magic, as we know this from other environments. Of course, dynamic models can be very complex. So to avoid freezing the entire scene, StereoKit is rendering them in steps. So this is what you see in the video. The model is loaded first, and then followed by the various textures and shaders. So it offers capabilities beyond a simple game engine. But are there any examples of StereoKit being used in a real-life application? There are, and I would like to show you a short video of one of the winners of this year's Mixed Reality Development Day StereoKit Hackathon. Oh, that's a mouthful. The author is a fellow Berliner and mixed reality enthusiast, Chris Papenfuss. So, hi Chris, if you're watching this, I'm showcasing your application. So the application is made for HoloLens and available in the Microsoft Store, and it's called Molecular. It's being used to visualize molecules, and for that, it pulls data from the PubChem database. You can see, there is the first molecule. And the database contains information about the molecule, similar structures, the structure and the structure description as well. The data is being used to render the molecule and also display additional data. You can see I'm now matching the molecules. Okay, so StereoKit can help you to overcome the device fragmentation and streamline your mixed reality development workflow. It can be used to develop applications in everybody's favorite language. I mean, C# obviously, but we learned that no one is stopping you from writing Java bindings. What else? Well, if you have debugged in Unity-based HoloLens application, you will know the pain. It's really painfully slow, and sometimes the remote debugger just doesn't want to cooperate. With StereoKit, you're not opening yet another instance of Visual Studio just to debug your scripts, but you deploy and debug directly from your single instance. This means less strain on your system and faster feature implementation. Speaking of time to run on the device, I recently spent some time measuring the time to build and deploy a simple template project containing only a single cube to a HoloLens device. I'm mostly developing for HoloLens, so this has been my device of choice. if you're not aware of the workflow for Unity-based HoloLens projects, you will need to build the project in the Unity editor first. This converts the entire scene with all the C# and mono-based C# scripts and packages to a C# C++ solution, hence the name IL2CPP, Intermediate Language 2 CPP. Once that solution is converted, you open up the solution in Visual Studio and hit Build and Deploy again. So in my few measurements, which are not representative at all, by all means, I never got below the 4-minute mark for both building processes alone. And this is ignoring the time to open up Visual Studio and loading the solution. When you just went back to Unity to scale a model or move it around, the consecutive builds will be obviously a lot faster and a lot smaller. As you can see, this is then 2 minutes and just a megabyte that is transferred. StereoKit shines especially in the very first run with a much faster and smaller deployment to the device. Subsequent builds are still considerably faster. Everything's fine?
Yes, Mark. We have just a few minutes left to wrap up the session. So if you can kindly help us wrap up. We have
really? I thought I have 40 minutes. Okay, got it.
Yes. So in 4 minutes, hopefully, if we can wrap up.
Oh, really? Oh, that's a big one. Okay, I'm doing my best because I have. So you guys miss out all the good samples then. So
yes, but it would be nice if we can have the slides as well, so the participants can have
yes.
a copy of it.
So as you can see, it's a lot smaller and is a lot faster. For the development or the time to run on the device is a lot faster. Okay, so I wanted to show you StereoKit in action with samples, code, and so on and so forth. The code will be on GitHub later today. I will probably also share the videos then. What I would like to share with you before I'm leaving you to the rest of these sessions is what we can do or what you need to do to get started. So you will need an IDE, preferably Visual Studio or Visual Studio Code, and an internet connection to download the NuGet package. A Visual Studio extension installs 2 templates to get started even quicker. If you aren't afraid of using the .NET commands on the command line, VS Code does the same and offers cross-platform development. And if you don't have a mixed reality device, no worries. If no device is detected, StereoKit can fall back to the flat screen mode. So your application will run on your desktop, interactions emulated by mouse and keyboard. If you have a device and is supporting the OpenXR standard, chances are high it will run StereoKit. The documentation on StereoKit is always up to date and the samples are directly pulled from code. Nick built an amazing documentation generator to keep his documentation updated. You can find all StereoKit resources under the StereoKit organization on GitHub, including all samples and all, basically all samples. It's worth checking them all out. Thank you very much, although it has been quite short.
Thank you so much, Mark.
You're welcome.
Yes. Do you have any questions for Mark? Maybe Mark can take just one question before we let him go. Any question for Mark? Okay, somebody is asking which of the OS is compatible with the StereoKit?
What is compatible? Sorry?
OS, operating system, is compatible with the StereoKit?
Any. I mean, so you run this on one of the devices like HoloLens or Oculus Quest or whatever, but you can develop on Linux, like everywhere where .NET is running. So Linux, Mac OS, and Windows, obviously.
Oh, okay, okay. We got you. So he said we can run on, across multiple platforms, whether we're using Linux, whether we're using it runs on both OS. Sorry? That's Windows OS. Okay. Somebody's asking about Apple iOS. Can you run it on iOS?
Yeah, you can develop, but you cannot. I mean, there is no Apple headset, so you can't run it on Apple. So you can build on Apple, but you can't run it there. I mean, you need a headset for that.
Okay. Thank you so much, Marc Plogas, for the very interesting session. So it's nice having you join the Tech Summit Nigeria 2022, Marc. Thank you very much.
Welcome. Have a great day. Bye.
Bye-bye.